Good evening, all. Welcome to Sankalp Learning Classes. So, in this session, we'll be discussing the chapter integrals. So, before starting the chapter, let me ask you a question. Haven't you all studied about differentiation, the process of differentiation, and as well as the application of differentiation in the last two chapters, isn't it? So, this is the basic knowledge that is required to enter into our new chapter, integrals. All right. So in mathematics, there is a branch called calculus, and this calculus has two main sub branches. One is differential calculus, and the other one is integral calculus. If you are going for engineering or higher studies and all, you will be dealing with calculus and the two parts, that is differential as well as integration, because these two parts plays an important role in engineering field. It has a wide range of application. All right. In that differential calculus, you study different methods of differentiation as well as the application of differentiation in the last two chapters. So in this chapter, we'll be dealing with the process of integration, different methods of integration, and in the next chapter, you will also study the application of integration also. All right. So, uh, so let me ask you a question. If you are given a function f of x, okay, can you find out the derivative of that function? If you are given an implicit function, you know the method of finding the derivative of an implicit function, isn't it? And if you are given a parametric function, you also studied the method of finding the derivative of a parametric function, isn't it? So you know, if f of x, if I am given a function f of x, then you know how to find out the derivative f dash of x, or it can also be denoted as d by dx if y equal to f of x, then we can also denote it as dy by dx, isn't it? We know d by dx is the notation of the derivative, isn't it? So if you are given the derivative of a function, okay, can you find out the original function? That is, you are given the derivative of a function. F dash of x is given. Okay, the first process is differentiation. That is, when you are given a function f of x, you can easily find out f dash of x. That is the derivative. Now, the second question is, if you are given the derivative of a function, that is f dash of x, can you find out the original function? That means the functions which derivative is given. Okay, the functions which derivative is given. Can you find out the original function? No, we haven't studied that process, isn't it? It is the reverse process of differentiation, isn't it? It is the reverse process of differentiation. So what do you mean by this reverse process of differentiation? It is nothing but integration. Okay, so what is integration? It is nothing but the reverse process of differentiation. All right, so for derivative, you know, this is the simple, isn't it? Similarly, you will also have a notation for integral also, isn't it? Integration, for the process of integration, it is nothing but the symbol. This is the symbol that is used to denote integration. All right. If you are given a function f of x and you are asked to find out the integral of that function, okay, integral is nothing but the resulting value or the resulting function that is obtained after integration, after the process of integration, is known as the integral of that particular function. All right, so this one is the symbol of integration, and if you are asked to find out the integral of the function f of x, you write integral f of x into dx, integral f of x dx. It is read as integral f of x dx. That is, the function is in the variable x, so you have to integrate it with respect to x. Okay, you have to integrate it with respect to x. That's why we have written a dx there. Okay, so what does this mean? Integral f of x dx means it is nothing but it is a process of integration. That is, you have to find out the integral of the function x with respect to x. If the function is in y, in the variable y, okay, if the function is in the variable y, then how will you find out the integral? It is nothing but integral f of y dy. It is nothing but integral f of y dy. If it is in the variable z, then how will you write? It is integral f of z into dz. Alright, I hope this much is clear to you all. Okay, now I'll explain all these theoretical part with the help of an example. Okay, now we dealt with the theoretical part of the process of integration. Now I'll give you an example of practically solving a question. Alright, so first of all, I'll ask you a question, that is, what is the derivative of x square? What is the derivative of the function x square? That is, the function is f of x is equal to x square. Okay, this is our function. You have to find out the derivative of x square. How will you find it? How will you find the derivative of x square? It is of the form x raised n. So it is nx raised n minus 1. Nx raised n minus 1. Here n is equal to 2. So the value will be 2 into x raised to 2 minus 1. That is 2x. Isn't it? D by dx of x square is nothing but, it is nothing but 2x. Okay. Now I'm taking integral on both the sides. If you are putting integral there, then you have to put dx also, because the function is in x, isn't it? The function is in x, so you have to integrate it with respect to x. Alright, so integral d by dx of x square is equal to integral 2x dx. Is that clear to you? Now, what is this integral and d by dx? Both are reverse process, isn't it? Differentiation and integration means integration is the reverse process of differentiation, or differentiation is reverse of integration, isn't it? So we can eliminate these two, isn't it? So this gets eliminated. So what will be the answer? X square is equal to integral 2x dx. X square is equal to integral 2x dx. All right. Now I am giving you another function, alright? That is, you have to find out the derivative of x square plus 1. The function is, the previous function was x square. Now I am giving you the function x square plus 1. You have to find out the derivative of x square plus 1. How will you do it? You can split this one and separately find the derivative, isn't it? If you can directly solve it, it is very good. D by dx of x square is nothing but 2x, isn't it? Plus d by dx of 1. It is a constant. Constant with respect to x, we are differentiating, which means the derivative of a constant is 0. Derivative of a constant is 0. So d by dx of x square plus 1 is nothing but 2x, isn't it? It is 2x. Again, what I am going to do is that same process, okay? I'm going to take, that is, we have got d by dx of x square plus 1 is equal to 2x. D by dx of x square plus 1 is equal to 2x. Alright, I'm taking integral on both the sides of the equation. So if you are taking integral, you have to put dx also, isn't it? So integral d by dx of x square plus 1 is equal to integral 2x dx. So these gets cancelled. So x square plus 1 is equal to integral 2x dx. Now what has happened now? Integral 2x dx has two values. Integral 2x dx, in the earlier case we got it as x square. The value of the function 2x. 2x is a function, isn't it? The value, the integral value of the function 2x was x square in the previous case, and now we have got the value of integral of 2x dx as x square plus 1. Both are two different functions. The base function is same. Base function is same, isn't it? Base function is x square, but both are different function. If you interpret it graphically, we know f of x is equal to x square is like this, and x square plus 1 means it will be like this. X square plus 1 will be like this, isn't it? And now, if you are given, I'm going to give you another function, that is, you have to find out d by dx of x square minus 5. X square minus 5. Then, what is the result? It is nothing but 2x. 5 is a constant. The derivative of a constant is 0. So, the derivative of x square is 2x. Okay, again, if you take integral on both sides, what will happen? This is x square minus 5 equal to integral 2x dx. Now we have got another function. Integral 2x dx is equal to x square minus 5. We have in the previous cases we have got integral 2x dx is equal to x square plus 1, isn't it? And in the first case we got integral 2x dx as x square. Okay, so we are getting different function, but here you can see that the base functions of the three are same. X square, isn't it? X square is a base function. So what is differing here? A constant, isn't it? Here this one you can write it as x square plus 0. This is x square plus 1. This is x square minus 5. So which means there is a difference in a constant, isn't it? There is a difference in a constant, and this constant is known as constant of integration. That means if we are finding the integral of a given function, we are actually getting a family of functions. The base function is same, but we are getting the family of that function. Okay, which means we are getting a family of integrals. This is an integral, this is also integral, this is also integral of the same function, isn't it? Of the same function 2x. That means we are getting a family of integrals, or integrals is otherwise known as antiderivative, because we know integration is a process, is a reverse process of differentiation. So integral is also called as antiderivative. All right, integral is also called as antiderivative. So here we are getting a family of antiderivatives, isn't it? So in order to represent that family of antiderivative, that is which is differing by a constant, we use a constant of integration called c. That is, if you are given a function f of x dx to find out the integral, you will definitely get a function, say it is as f of x, okay, f of x, but there will be a change in a constant. So in order to represent that, you put a c along with that, along with the solution, that is f of x plus c. You should definitely add, never forget to add the constant of integration, because while integrating a function we are getting a family, not a single function. Okay, that is the representation of a family. So we have to definitely add a c, and this one is called the family of antiderivatives. And here you can see that if I draw x square minus 5, this it will be like this. Okay, it will be like this, x square minus 5. So again if I take another function x square minus 4, then it will be like this. So we are getting a family of antiderivatives of the function 2x. Okay, so that is denoted by f of x plus c, and c is known as constant of integration. These are all given in the slides. That is, the process of finding f of x when its derivative f dash of x is given is known as integration. It is the reverse process of differentiation. Okay, I think it is clear to you. Now we studied about what is an integral. The resulting value after the process of integration is known as integral, and it is otherwise known as antiderivative. And while integrating a function, we are getting a family of antiderivatives or family of integral, and that's why we always add a constant of integration along with the function obtained. All right. So these are all explained. Constant of integration is also explained. Now Now we need some standard results for solving these integration questions. All right. If you know the standard results of differentiation, okay, we have studied some standard results in the chapter differentiation. If you know that, it will be very easy for you to study the formulas or the standard results in integration, because both are reverse process of each other, isn't it? So it will be very easy. You don't need to by heart anything. Okay, if you know, if you can think like that, if this is an inverse process, if one derivative is known, then you can easily find out the integral of that function. All right, so we'll do some of the standard results. That is, what is d by dx of sin x? Okay, what is d by dx of sin x? What the derivative of sin x is? Sin x is cos x, isn't it? Now, if I take integral on both sides, what will happen? Integral on both sides, then this gets eliminated, this gets eliminated. So sin x is equal to integral Integral cos x dx. Okay. So what is integral cos x dx? Integral cos x dx is equal to not sin x. We should definitely add a constant of integration. It is sin x plus c. Okay. Integral cos x dx is equal to sin x plus c. All right. So if you know the derivative of sin x is cos x, then think in reverse. Derivative is cos x, then what will be the integral of cos x? Integral of cos x will be sin x plus c. All right. Now we are going to derive the second formula, that is d by dx of cos x. D by dx of cos x is nothing but d by dx of cos x is nothing but minus sin x, isn't it? Minus derivative of cos x is minus sin x. So if you take integral on both sides, what will happen? Cos x is equal to integral minus sin x dx. Integral minus sin x dx is cos x, but we need the formula for integral sin x. Okay, integral sin x. So you take that minus to the other side. Integral sin x dx will become minus cos x plus c. Okay, this was plus cos x, and if you take this minus to the other side, it will become minus cos x plus c. All right. Similarly, we can derive all the other functions, all the formulas for standard results for other functions as well. That means tan x, the derivative of tan x is, what is the derivative? Sec square x, isn't it? Sec square x is the derivative of tan x. So what will be the integral? Integral of sec square x dx. You can definitely say this is the reverse process. So it will be definitely tan x but plus c. Since it is integration, you have to add the constant of integration. All right. Now next one, d by dx of cot x. Cot x is equal to minus cosec square x. Cot x is equal to minus cosec square x, isn't it? So what will be integral minus cosec square x? Integral minus cosec square x dx will be the reverse process, isn't it? So this is equal to cot x plus c, but we need to know what is integral cosec square x dx. Okay, we need to know what is integral cosec square x dx. So take this minus to the other side. So this will become minus cot x plus c. Minus cot x plus c. Here there is no importance in the sign because this is representing an arbitrary constant. Minus c, it can be minus or plus. Just you add it as plus c. All right. All right. So it is minus cot x plus c. Now next one is d by dx of sec x. Okay, d by dx of sec x. What is the derivative of sec x? Derivative of sec x is sec x tan x. Derivative of sec x is sec x tan x. So what will be the integral of sec x tan x dx? What will be the integral of sec x tan x dx? It is nothing but sec x plus sec x plus c. Sec x plus c. All right. Next one is d by dx of cosec x. Okay. D by dx of cosec x is equal to minus cosec x cot x. D by dx of cosec x is minus cosec x cot x. So integral of minus cosec x cot x will be cosec x, but we need cosec x cot x, isn't it? So cosec x cot x is equal to cot x dx is equal to, that will be minus cosec x plus c. Minus cosec x plus c. All right. Now moving on to our next result. That is integral x raised to n dx is equal to x raised to n plus 1 by n plus 1 plus c. Okay, which means I'll explain it with the help of an example. That is, if you are given a function integral x square dx, or you take it x cube dx. Okay, you are given a function x cube ds. You have to integrate that function. So you can apply this one. It is of the form x power n, where n is equal to 3. Okay, x cube means you can compare it with the function x raised to n, isn't it? The base functions both are same. The power n is equal to, here it is equal to 3. So what is happening here? What is the result? X raised to n plus 1 by n plus 1. You add 1 along to the power of x, isn't it? You add 1 to the power of x. Here power of x is 3. So which means the integral will be, what will be the integral? X raised to 3 plus 1 by 3 plus 1 plus c. Okay, what is 3 plus 1? 4. X raised to 4 by 4 plus c. X raised to 4 by 4 plus c. Alright, moving on to let's do one more example. Alright, that is integral x raised to 7 dx. What will be the integral of this function x raised to 7? Here n is equal to 7. Just add 1 to the power, isn't it? So this is equal to x raised to 8 by 8 plus c. X raised to 8 by 8 plus c. Alright, now moving on to another result, that is integral dx. What will be integral dx? There is no function. So you can write this one as integral 1 into dx. It is a constant 1. It is a constant function 1. Okay, 1 into dx is dx itself, isn't it? So how will you connect it with the previous result? 1 can be written as x raised to 0. Any number raised to 0 is 1. So x raised to 0 is also 1. So integral 1 dx can be written as integral x raised to 0 into dx. Okay, integral 1 dx can be written as integral x raised to 0 into dx. Okay, now if you apply the result, x raised to n plus 1 by n plus 1. This is of the form x power n where n is equal to 0. So if you apply that result, what will be the integral? X raised to 0 plus 1 by 0 plus 1 plus c. Isn't it? What is x raised to 0 plus 1? X raised to 1 by 1 plus c. So what is the value? X raised to 1 is x itself, and divided by 1 again x itself. So x plus c. So what is the result that you have obtained now? Integral dx. Integral dx is nothing but x plus c. Integral dx is nothing but x plus c. Okay. Now moving on to our next result. And you know the derivative of sine inverse of x. Sine inverse of x. What is the derivative of sine inverse of x? 1 by root of 1 minus x square. 1 by root of 1 minus x square. So what will be the integral of 1 by root of 1 minus x square into dx? It will be sine inverse x plus c. Sine inverse x plus c. Okay. So similarly, if it was integral minus 1 by root of 1 minus x square into dx, it was minus 1 by root of 1 minus x square into dx. So you think which function's derivative is this? Which function's derivative is this? Derivative of cos inverse x. Derivative of cos inverse x is minus 1 by root of 1 minus x square. So what will be the integral of minus 1 by root of 1 minus x square? It is equal to cos inverse x plus c. It is equal to cos inverse x plus c. Alright, now we have studied some more derivatives. We studied about the derivative of tan inverse x also, isn't it? What was it? What was it? I'll explain it with the help of the slide. Okay, so tan inverse x, the derivative was 1 by 1 plus x square. So the integral of 1 by 1 plus x square dx will be tan inverse x plus c. All right, and now we have studied that the derivative of sec inverse of x, the derivative of sec inverse of x is 1 by x root of x square minus 1 dx. Okay, the derivative of sec inverse x is 1 by x root of x square minus 1. So what will be the integral? Integral 1 by x root of x square minus 1 dx is equal to sec inverse x plus c. Okay, if it was minus, if it was minus, it will be, if it was minus, it will be cosec. Okay, it will be cosec inverse of x plus c. Okay, now another important result is integral e raised to x dx. Integral e raised to x dx. So we know the derivative of e raised to x. What is the derivative of e raised to x? E raised to x itself. So if you take the integral of e raised to x, what will be the integral? It is nothing but e raised to x itself. Okay, e raised to x plus c. Integral as well as the derivative of the function e raised to x is nothing but e raised to x itself. Alright, since this is integration, you have to add the constant of integration, that is plus c. E raised to x plus c. Okay, now next one is a raised x, you know the derivative of a raised x. Derivative of a raised x is a raised x into log a. Derivative. So we need to find out the integral of a raised x. So integral of a raised x will be a raised x dx will be a raised x. This log a is a constant, isn't it? So we can take it to the other side. So this is log a plus c. A raised x plus log a plus by log a plus c. Alright, now next one is another important result. This one, integral 1 by x dx is equal to log mod x plus c. Log mod x plus c. Here you know that the derivative of log x. What is the derivative of log x? It is 1 by x. Derivative of log x is 1 by x. So you think it reversely. That is, what will be the integral of 1 by x? Integral of 1 by x dx will be nothing but log x. Log mod x plus c. This mod or absolute value is written because log cannot take negative values, isn't it? So that's why we have put a modulus here, absolute value here, log mod x plus c. So 1 by integral 1 by x dx is nothing but log mod x plus c. Okay, so these are some of the important results that you need to know in order to solve all the problems of this session. All right. If you know the derivatives properly, then you can easily connect it because both are reverse processes. If you get one thing, you will definitely get the formula for the integration also. All right. Now, the next one is properties of integral. You have studied different properties in differentiation as well. Here we are going to study the properties of integral. So, which is the first property given here? Integral f of x plus g of x into dx is equal to integral f of x dx plus integral g of x dx, which means we can separately find the integral if it is given as a sum of two functions. If a given function is sum of two separate functions, then we can separately find the integral and then add it. Okay, it's same as the process of differentiation. For example, if you are given a function integral sorry for the interruption. So if you are given a function integral sine x plus cos x, sine x plus cos x into dx. Okay, you have to find out the integral of this particular function, that is integral sine x plus cos x dx. Both are two different functions and uh, you can apply this result, isn't it? So you can separately find the integral sine x dx plus integral cos x dx. Separately you find the integral and then add it. Okay. So what is integral sin x dx? You think the derivative of sin x. What is the derivative of sin x? Sin x is cos x, isn't it? So you will get the integral of cos x, isn't it? So integral sin x dx is equal to minus cos x, isn't it? Minus cos x. Integral sin x dx is equal to minus cos x. And similarly, what is integral of cos x dx? Cos x dx, you think which function's derivative is cos x? Sin x derivative is cos x. The function sin x derivative is cos x. So what will be the integral of cos x? Integral of cos x will be sin x. Okay, derivative of sin x is cos x. Okay, derivative of cos x is minus sin x. So you think it reversely. Cos x will become sin x and sin x will become minus cos x. Okay, minus cos x plus sin x plus c. Alright, now moving on to the second property. So what is the second property? It is integral f of x minus g of x into dx is equal to integral f of x dx minus integral g of x dx. Here the only difference is that it is subtraction of two functions, isn't it? So here also you can separately find the integral and then subtract it. Okay, that is if you are given a function integral x square minus x cube, integral x square minus x cube into dx. What you have to do, you have to apply the property, that is integral x square dx minus integral x cube dx, integral x square dx minus integral x cube dx. So what is the integral of x square? We have studied the result, x raised n is x raised n plus 1 by n plus 1. Okay, so here n is 2. So just add 1 with 2. That is x cube by 3. X cube by 3 minus x raised to 3 will become x raised to 4 by 4 plus c. Okay, you just add one constant of integration. You don't need to separately add two constant of integration. You can club it together and then just add in the end a c. Okay, that is x cube by 3 minus x raised to 4 by 4 plus c. All right, now we are moving on to the third property. Third property is integral k into f of x dx is equal to k into integral f of x dx. Okay, how will you do this? How do you do this? I'll explain it with the help of an example. That is, k means nothing but it is a constant. K is a constant. If a constant into a function, if you are asked to find out the integral of a constant into a function, then you can take that constant outside and then you can multiply with the integral of the given function. Okay, that is for example, if integral 4x square dx, 4x square dx, okay, x square is a function, x square is a function, 4 is a 4 is a constant. So constant, it is of the form constant into some function. So you can take that constant outside. So this is equal to 4 into integral x square dx, 4 into integral x square dx. All right. So what is the integration of x square? In integral of x square is nothing but x cube by 3. Just add 1 to the power x cube by 3 plus c. So this can be written as 4 by 3 x cube plus c. So this is the integral of that particular function. So if you are given a function like this, that is integral 7 into sin x, 7 into sin x dx. Okay, 7 into sin x dx. So what will you do? 7 is a constant, sin x is a trigonometric function. So what you have to do according to this property, take that 7 outside, isn't it? So I'm taking that 7 outside. Integral sin x dx, integral sin x dx. Okay, so this is equal to 7 into, what is the integral of sin x? Derivative of sin x is cos x. So what will be the integral of sin x? Just change the sign. Okay, that is minus cos x. Minus cos x. Okay, derivative of sin x is cos x. Integral of sin x is minus cos x. 7 into minus cos x plus c. So this can also be written as minus 7 cos x plus c. Minus 7 cos x plus c. All right. I hope the three properties are clear to you all. Now we are moving on to the integration part. Okay. So before discussing the integration by substitution, so actually there are the methods of integration can be divided into, mainly it can be divided into three parts. That is, first one is integration by substitution, and then integration by partial fraction, and the third one is integration by parts. All right, before all these methods, some functions we can directly integrate. Okay, we can, since we have studied the standard results of many functions, some functions we can directly integrate with the help of those standard results. So first we'll discuss a few problems that can be solved using direct integration, and then we'll discuss these methods of integration. All right, so we'll do one or two problem from direct integration. So if you are given a function integral 2x square plus e raised x into dx. Okay, integral 2x square plus e raised x into dx. So according to the property that we have discussed earlier, how will you do this? Just split the integrals as two functions. Okay, that is integral 2x square dx plus integral e raised x dx. Alright, and what is the integral of 2x square dx? Again here, another property, third property can be used, isn't it? The constant 2 can be taken outside, the rest, the function can be placed in the integral sign, isn't it? So 2 into integral x square dx plus integral e raised to x into dx plus integral e raised to x into dx. Alright, so what is the integral of x square? 2 into x cube by 3. You just add 1 with 2, isn't it? So x cube by 3 plus what is the integral of e raised x? E raised x is e raised x itself, plus finally you add a constant of integration, that is c. So this can be written as 2 by 3 x cube plus e raised to x plus c. Just rearranging it. Okay, so this is the integral of the given function 2x square plus e raised to x into dx. Okay, now moving on to the next question. That can be done with the help of direct integration itself. Alright, so integral 2x minus 3 cos x 3 cos x plus e raised x into dx. Integral 2x minus 3 cos x plus e raised x into dx. Again apply the property, that is integral 2x dx minus integral 3 cos x dx 3 cos x dx plus integral e raised x into dx plus integral e raised x into dx. Alright, here you take the constant outside. Okay, using the third property. So 2 into integral x dx minus 3 into integral cos x dx plus integral e raised x dx. So what is the result here? What is the result here? 2 into x power 1. This is x dx means x power 1, which means you have to add 1 with 1. Isn't it? So it will become 1 plus 1 divided by 1 plus 1. So this is x raised to 2 by 2 minus 3 into integral of cos x. Integral of cos x is, we know derivative of cos x is minus sin x. So integral of cos x is sin x. Okay, so 3 into sin x plus e raised x. Integral of e raised x is e raised x itself. Okay, plus c, constant of integration. Here you can see that these are all can be integrated using the standard result. Okay, that is direct integration. You don't need to substitute any values in order to find the integration of these type of functions. You can directly integrate it. Okay, there are many problems in the first exercise. You can do it. Then you will be thorough with these type of integration and as well as the standard results also. All right. So we are moving on to the methods of integration. So this integration by substitution, we'll be discussing integration by substitution in this class. So integration by substitution means this itself we can divide it into four or five types. Okay, the integration, then it will be easier for you to understand. Okay, we can just group certain things into a certain form, and then it will be easy for, especially when you solve 1 mark questions and all, you can directly write the answer by using that result. Okay, so integration by substitution is nothing but we are replacing this function f of x. Okay, that is the variable x is replaced with another function. Okay, variable x is replaced with another function and then you solve it using the standard result. That is what meant by integration by substitution. So in this case, we'll first consider the functions of the type f of ax plus b. Okay, f of ax plus b. So how will you find out the integral of f of ax plus b, the functions of the form f of ax plus b. What is this ax plus b? Ax plus b is a linear polynomial. What do you mean by a linear polynomial? The power of x is 1. Power of x is 1. Such polynomials are called as linear polynomial or linear function. It is a linear function, isn't it? If you are given a function x square, then this becomes a quadratic function. The power is 2. It is not linear. So this result can only be applied. Now I'm going to say a result or derive a result, and this can be this result is only applied to linear polynomials. All right, that is the polynomials of the form ax plus b or functions of the form ax plus b. F of ax plus b, that is in the place of x a linear polynomial comes. Okay, in which means if you are given a function f of x, in the place of x, the variable x, there will be a linear polynomial, that is it will be of the form ax plus b. Okay, so here what we are going to do is that if in the place of x a function comes, ax plus b comes, we'll change it into another variable. That is, we are going to substitute ax plus b as some other variable other than x. You can take any letter other than x. So here I am going to substitute it with u. Ax plus b is equal to u. Okay, you can use t or any other variable other than x. Since this is a function in x, you can't use that. Ax plus b equal to u. All right. So how will you find out the derivative of ax plus b? Derivative d by dx of ax plus b is equal to du by dx. This u is actually a function, isn't it? So it is not in x. So you should write it as du by dx itself. And this b is a constant. This x can be differentiated with respect to x. A can be taken outside, isn't it? So this is a into d by dx of x plus d by dx of b is equal to du by dx. All right. So what is the differential of x? D by dx of x is nothing but 1. A into 1 plus derivative of a constant. B is a constant. So it is 0. This is equal to du by dx, which means a into 1 is a. A equal to du by dx. We have got a equal to du by dx. If we take this dx to this side, this will become a into dx is equal to du. A into dx is equal to du. From this you get dx is equal to du by 2. Okay, now again come back to the question. It was f of ax plus b, isn't it? It was f of ax plus b. Okay, so I'm going to give the substitution. So that is integral f of ax plus b dx. We have to find out the integral of this particular function. Now what I have done is that I have given a substitution u. So this can be replaced as integral f of u. Ax plus b can be replaced as f of u into what is dx? What is dx? Dx is nothing but du by 2. From this we have got that dx is nothing but du by 2. Du by 2. Okay, here you can take this 1 by 2 outside, this 2, you can take it outside, 1 by 2 into integral f of u du. Now you can, with the help of standard integral, we can integrate the function. Okay, this is purely the theoretical part. We'll just do some problem, 2 or 3 problem, then you will understand the concept. All right. So and after that we'll find an easy way also in order to solve these type of problem. If it is asked for 1 mark question, okay, if it is asked for 2 mark question, you can give the substitution and then derive it as done earlier. All right, that is integral. The first question is integral sine 2x dx. Integral sine 2x dx. Okay, here you can see that the basic function is sine x. The basic function is sine x, but in the place of variable x, you can see that there is another function. 2x is a function. Okay, in the place of x, variable x, it is a function 2x, and that function is a linear polynomial. That function is a linear polynomial. How did you identify that it is a linear polynomial? The power of x is equal to 1. Power of x is 1. So it is a linear polynomial. So we can apply the result. That is, you give substitution to the function within the sine function. Okay, function within the sine function or within the base function. Which is that function? It is 2x. So you give substitution for 2x. So when you give substitution for 2x, 2x is equal to, let 2x is equal to u. Okay, in this problem I'll once again I'll do the step, that is 2 into, you have to find out the derivative of 2x and u with respect to x. Okay, that is d by dx of 2x is equal to du by dx. All right, so here 2 can be taken outside. So it will be 2 into 1 equal to du by dx, which means 2 dx is equal to du. 2 dx is equal to du. From the next problem onwards, I'll skip this step. Okay, I'll skip this step. I'll directly write 2x equal to u. Then the differentiation is 2 dx equal to du. All right. So we have got 2 dx equal to du, and now we need a substitution for dx also. Since we are substituting 2x as u, we have to change the complete value or complete function in terms of x. Okay, so you have to change this dx also. Dx should also be converted into u. So that is why I wrote dx is equal to du by 2. You can't write like this, okay? That is integral sin u dx. This is wrong. Sin u dx, it is wrong. You can only write integration completely in one variable. If it is u, then you should write sin u du. If it is x, then you should write sin x dx. All right. Now, again, coming back to the question can be replaced with u. Integral sin u du. Integral sin u du by 2. Not du by 2. Dx is du by 2. Okay, so here you can take 1 by 2 outside. So 1 by 2 integral sin u du. 1 by 2 integral sin u du. Okay, so don't you know the integral of sin x? Integral of sin x is minus cos x. Integral of sin x is minus cos x. Here the variable is in u. So what will be the integral of u sin u with respect to u? What will be the integral? It is nothing but minus cos u. Okay, it is nothing but minus cos u. 1 by 2 into minus cos u plus c. Now, since the question is in x, the answer should also be in x. That is, the integral should also be in the variable x. Okay, the function is in x. So, the resulting integral should also be in x itself. So, you have to resubstitute the value for u. What is the value for u? The value for u was 2x. So resubstitute that value, that is 1 by 2 into minus cos 2x plus c. 1 by 2 into minus cos 2x plus c. Okay, so this can be written as minus cos 2x by 2 plus c. Okay, now we'll take another function. Okay, we'll take another function. That is integral e raised to 2x plus 3 dx. Integral e raised to 2x plus 3 dx. Here also you can see that the base function is e raised x. The base function is e raised x, but in the place of x, you can see a linear polynomial, that is 2x plus 3. So you can give the substitution for 2x plus 3. Okay, in the differentiation and all, if it is e power tan x also, we can assume that is tan x as x, and then you can find the derivative using the method called derivation of composite functions, isn't it? Here in the integration process, you can only assume the linear polynomial as x. Okay, you can't take, if you are given a function e raised to x square, this is not linear. You can't assume it as x and then solve the problem. That is wrong. If it is only linear polynomial, if the power of x is 1, then only you can assume it as x and then solve it using the result. Okay. So here, which function will be given the substitution? It will be 2x plus 3, isn't it? Linear polynomial 2x plus 3 is given as u. Okay, so here I am writing directly the differentiation. Okay, that is 2 is a constant. Derivative of x is 1. So 2 dx, and this 3 is the derivative of 3 is 0. 2 dx is equal to du. Actually, this dx is obtained from du by dx. Okay, so I am skipping that step. So this one is 2 dx is equal to du. 2 dx is equal to du. All right. So here, so we can replace dx also. Dx is equal to du by 2. Dx is equal to du by 2. So coming back to the question, e raised to 2x plus 3. 2x plus 3 is u. So replace it with u. then dx should also be replaced in terms of x. So dx is nothing but du by 2. So this is equal to du by 2. By 2 means 1 by 2. Okay, that is a constant. So you can take it outside. 1 by 2 integral e raised to u into du. 1 by 2 integral e raised to u into du. So what is the value of this? 1 by 2 into, what is the value of integral e raised to x with respect to x, e raised to x dx? It is nothing but e raised to x plus e. Here, in the place of x, it is the variable u. So we can use the standard result itself. The variable has just got changed. That is, it is in terms of u. Okay. So 1 by 2 integral e raised to u du is equal to in e raised to u plus c. Okay, 1 by 2 e raised to u plus c. We can't stop here because the given function is in x, variable x. So you have to write the result also, the integral also in terms of x. So resubstitute that value, that is 1 by 2 e raised to 2x plus 3 plus c. E raised to 2x plus 3. So this can be written as 1 by 2, 1 by 2, sorry, e raised to 2x plus 3 by 2. Okay, both are same. 1 by 2 into e raised to 2x plus 3 and e raised to 2x plus 3 by 2 are same. Okay, now can you identify any peculiarity for these two functions? What is happening here actually? Here, when you are given sine 2x, if you observe the result, you know sine x is minus cos x. Sine x is minus cos x. So what is sine 2x? Sine 2x is minus cos 2x, since we have assumed x as 2x. Okay, x as 2x. What is happening there? The derivative of 2x. What is the derivative of 2x? Derivative of 2x is nothing but 2, isn't it? So they are dividing the derivative to the resulting value, isn't it? Minus cos 2x divided by 2 plus c. From where this 2 is obtained? It is nothing but the derivative of the linear polynomial 2x. Now coming back to this question. Okay, e raised to 2x plus 3 by 2 plus c. Here also, if you observe that this was a function. Okay, e raised to x is, we know the integral is e raised to x plus c. Here, what is the difference? In the place of x, it is 2x plus 3, because the question is in 2x plus 3, a linear polynomial. So, e raised to 2x plus 3 itself. But since we have assumed 2x plus 3 as x, we have to divide the derivative. Okay, which is dividing? The derivative of the linear polynomial is divided. Okay, the derivative of the linear polynomial 2x plus 3 is 2. So you have to divide it with 2 plus c. Okay, e raised to 2x plus 3 divided by 2 plus c. All right. Now we can easily solve these type of questions if it is asked for 1 mark question. We have generalized the result, isn't it? That is, if it is given integral cos of 4x plus 1. First, identification is very important. Identifying which method is to use in order to find the integral is very important. Okay, so here itself you can see that cos is the base function. Cos x is the base function, but in the place of x, you can see that there is a linear polynomial 4x plus 1. Since it is a linear polynomial, we can assume it as x and directly find the integral as the standard result. That is, what is the result of integral cos x dx? Cos x means it is sin x, isn't it? Integral cos x dx is sin x plus c. It is sin x plus c. Okay, so what will be integral cos of 4x plus 1? We can assume 4x plus 1 as x and then integrate. So this will be sine of 4x plus 1, but we can't stop here because it is not x. It is a linear polynomial. So we have to divide the derivative of this linear polynomial. Always a linear polynomial, the derivative will be the coefficient of x. Here the coefficient of x is 4. That will be the derivative, isn't it? So you can divide it with 4 plus c. Sine of 4x plus 1 divided by 4 plus c. If it is asked for 2 mark question, you can give substitution for 4x plus 1 equal to u and then solve it as in the previous question. Alright. So if it is asked for 1 mark, you can directly write it from the options. Alright. So 1 by 3x plus 2, 1 by 3x plus 2 dx. Here also you identify the base function. It is of the form integral 1 by x dx. But in the place of x, you can see that it is a linear polynomial. What is it? 3x plus 2. It is a linear polynomial 3x plus 2. So we can as usual find the integral. But what we have to do is that we have to divide the derivative of the linear polynomial that we have assumed as x. Okay, so here what will be the result? We know integral 1 by x is log mod x plus c, log mod x plus c. So here it will be log mod 3x plus 2, because in the place of x it is 3x plus 2. But you can't stop here, you have to divide the derivative of this linear polynomial. What is the derivative of this linear polynomial? The coefficient of x, it is 3, isn't it? Log mod 3x plus 2 divided by 3 plus c. All right, now moving on to the next type. So here they have given you some of the important functions, that is of the form f of ax plus b. All right. So this one we have discussed. Sine of ax plus b will be minus cos of ax plus b, and the derivative of ax plus b is a. So you should divide it with a. Okay. Similarly, here cos of ax plus b, we know cos of x is sine x. So cos of ax plus b, sine of ax plus b, but the derivative of ax plus b is a. So you have to divide the derivative. Divide the derivative. Okay. So similarly, some of the functions is given here. Now we are moving on to the next type, that is by substitution itself, but the next type in that substitution. All right, integration of the function of the type f dash of x by f of x, f dash of x by f of x. That is, the function should be of the some rational form, f of x by g of x. And what is the condition? That is, this numerator should be the derivative of the denominator. Numerator should be the derivative of the denominator. Here f of x is the denominator and the derivative is f dash of x, that is the numerator. So this is of the form f dash of x by f of x. So you can first we can derive the result. Okay. So integral f dash of x by f of x dx. This is also done by substitution method itself, but we are grouping into two different types in order to make our integration process easier. All right. So integral f dash of x by f of x dx is equal to log mod f of x plus c. Log mod f of x means denominator. Log mod denominator. Every function which is of the form which satisfies this form, the result will be log mod f of x. Which function is in the denominator? That plus c. Alright, so here what you are going to do is that you are going to give substitution for f of x for the denominator. Okay, f of x is equal to u. So this will become f dash of x into dx is equal to du. F dash of x into dx is equal to du. Okay, so what is f dash of x? Here you can see this is f dash of x into dx, that is du. So the question can be replaced as integral du by what is f of x? F of x is equal to u. Okay, du by u can also be written as 1 by u into du. Both are same. Okay, both are same. So what is the integral of 1 by u with respect to u? 1 by x with respect to x is log mod x. So 1 by u with respect to u will be log mod u plus c. Log mod u plus c. But here the function is in x, variable x. So you have to convert it into variable x itself. What was u? U is f of x, log mod f of x plus c. So this is the theoretical part. This is how we applied the result. That is integral f dash of x by f of x dx is equal to log mod f of x plus c. Now we'll do two problems from this. So the first one is integral 2x by 1 plus x square into dx. 2x by 1 plus x square into dx. Okay, first identify the type. Okay, can we directly integrate it? No, we haven't studied any formula for 2x by 1 plus x square, so we can't directly integrate it. Now, next method, integration by substitution. So the first method was a polynomial, linear polynomial within a another function, that is f of ax plus b. It is this of the form f of ax plus b? No, so we can't apply that. Now it comes a second type, that is f dash of x by f of x dx. Does it satisfy that condition? We can substitute f of x as u. Here the denominator is 1 plus x square, so just put 1 plus x square as u. 1 plus x square equal to u. So this is equal to 2x dx. 1 The different derivative of 1 is 0. Derivative of x square is 2x. Okay, 2x is equal to, so this will be actually 2x is equal to du by dx. You take this dx to the other side, so you can write 2x dx is equal to du. 2x dx is equal to du. Okay, now can we replace this function 2x dx with du? Integral du divided by what was 1 plus x square. 1 plus x square is u. So du by u, which means integral 1 by u du, which is the result is log mod u plus c. And what is this u? What is this u? Here in this question, u is nothing but log mod 1 plus x square plus c. Log mod 1 plus x square plus c. If it is asked for 2 mark, you expand it like this. Otherwise, that is by giving substitution and all. Otherwise, if it is asked and if you are easily able to find out the derivative of 1 plus x square is 2x, if we can calculate in mind itself, that is the derivative of 1 plus x square is 2x. So this is of the form integral f dash of x divided by f of x into dx. Then you can directly find the result from the answers. Okay, log mod f of x, that is mod denominator. This is denominator function plus c. Okay, here also you have got it as log mod 1 plus x square plus c. All right, now we can we should derive a standard result using this method of tan x and all. We haven't studied the integral of tan x dx, so with the help of this result we can easily find out what is the integral of tan x. Okay, so can you find out the integral of tan x using this method? First of all, if you have to apply this method, this should be of the form f of x by g of x. Is tan x is of the form a rational function? No, it is just a trigonometric function. So can we convert this into that form rational function? Yes, because tan x is nothing but sin x by cos x. So you can write it as sin x by cos x into dx. Integral sin x by cos x into dx. Okay, here now you check whether the derivative of the denominator is the numerator. What is the derivative of cos x? What is the derivative of cos x? D by dx of cos x is minus sin x. It is minus sin x. Here, but there is only sin x. There is a uh, minus less, isn't it? So what I'm going to do is that I'm going to make an adjustment. That is, I'm going to put a minus here, minus sin x by cos x. Now the question has changed, isn't it? So in order to make it tally, that is, I'm going to put a minus here. Okay, minus into minus will become plus. So it is same as this question, integral sin x by cos x dx. Okay, so now can you compare this of the form f dash of x by f of x? Here f of x is cos x, f dash of x is minus sin x. F dash of x is minus sin x and the derivative of cos x is minus sin x. So it is of the form f dash of x by f of x. So we can write log mod, minus is outside here, log mod denominator. What is the denominator? Cos x plus c, minus log mod cos x plus c. Okay, there is another property for log a, that is minus log a can be written as log 1 by a. Okay, log 1 by a. So if you take this minus inside, this will become log mod 1 by cos x. Log mod 1 by cos x plus c. Okay, so what is 1 by cos x? 1 by cos x is reciprocal of cos x is sec x. So log mod sec x plus c. Log mod sec x plus c. So what is the integral of tan x? It is nothing but log mod sec x plus c. Okay, so that is given in the slide here. Integral tan x dx is equal to log mod sec x plus c. Similarly, we can derive these results also. Okay, using the same result, we can derive all these results. That is integral cot x dx is equal to log mod sin x plus c. Integral sec x dx is equal to log mod sec x plus tan x plus c. Similarly, integral cosec x dx is equal to log mod cosec x minus cot x plus c. You have to study along with the standard result that we discussed in the beginning of the session. Okay, these are all important. All right. Now there is the fourth type is substitution itself, but it will be of the form integral phi of f of x into f dash of x dx. Phi of f of x into f dash of x dx. That is, you can see this is a base function. Phi of x is a base function, but in the place of x you can see another function, it is f of x. Okay, and the derivative of f of x is outside. Okay, so this is the fourth type, integral phi of f of x into f dash of x dx. Here also we put f of x is equal to u. Okay, f of x is equal to u. So f dash of x into dx will become du. So this can be rewritten as integral phi of u du. Now you can f dash of x dx is replaced with du. Okay, now you can use the above the earlier types in order to solve this one. Okay, I'll do a problem, then you will understand this type. That is integral 2x into sine of x square plus 1 dx. Integral 2x into sine of x square plus 1 dx. Alright, so here you can see that you compare it with the function phi of f of x into f dash of x. Okay, so first you need to find out which is the phi of x here. So first you consider 2x. 2x is just a function, isn't it? It is not a function within a function. It is not of the it is not a composite function. Now consider sine of x square plus 1. It is a composite function because the base function is sine, but in the place of x you can see that it is another function. It is nothing but x square plus 1. All right. Now, if you consider this one as f of x, x square plus 1 as f of x, can you see the derivative of that function in that question? What is the derivative of f of x, x square plus 1? It is 2x, 2x dx. Derivative of x square plus 1 is 2x dx. So you can see here 2x into dx is there. So you can directly give the substitution for x square plus 1 as u. So you'll get 2x into dx is equal to du. So you can rewrite this as sine u into du. Sin u into du. What is the value of sin u? Sin x is minus cos x plus c. So sin u will be minus cos u plus c. Minus cos u plus c. And what is this u? You have to change it into x itself. Okay, so resubstitute it. So minus cos of x square plus 1 plus c. Minus cos of x square plus 1 plus c. Now we'll do one more problem from this session and we'll wind up this session. Okay. That is the second one is integral sine of tan inverse x, sine of tan inverse x by 1 plus x square into dx. Okay, now you have to identify which type is this. You can directly integrate, isn't it? It is not of the form f of ax plus b. It is not of the form f dash of x by f of x. Now the next type is this one itself, which is that phi of f of x into f dash of x. Phi of f of x into f dash of x. Isn't it? Here you identify the base function. This can be rewritten as sine of tan inverse x into 1 by 1 plus x square. Okay, both are same. Now if you consider this as phi of x, you can see that in the place of x there is another function. It is nothing but tan inverse x, and the derivative of tan inverse x is 1 by 1 plus x square. That is also given in the function 1 by 1 plus x square. Okay, so which function is substituted here? Tan inverse x is equal to u. Put tan inverse x equal to u. So 1 by 1 plus x square, that is the derivative of tan inverse x into dx equal to du. Alright, so here we have got this one as du, and this can be written as sine of u. Tan inverse x is u. Sine u into this one is du. Sine u du. Okay, what is the integral of sine x dx? Cos x dx. So what will be the integral of sine u du? It is nothing but minus cos u plus c. Okay, sine u is minus cos u plus c. So what is u here? U is nothing but tan inverse x. So minus cos of tan inverse x plus c. Okay, so this is the integral of the given function. All right. Now we have two more types in the integration by substitution. That is by integration by using trigonometric identity. That is we substitute trigonometric identities and then we'll find the integral of certain function. and integration of some special functions are also included in this session that we will discuss in tomorrow's session. I hope this session was useful to you all. What you have to do is that you have to be thorough with the standard results and differentiation, then you will automatically understand or will be able to find out the standard results of integration. And definitely you should know how to find out the derivative of different functions, then only you can find out the integration of functions. And for the next session, for tomorrow's class, you should know different trigonometric identities, then only you can substitute for the questions and find out the integration. All right, so that is given in these slides. So these equations or trigonometric identity that you have studied in +1, you should be familiar with. All right, okay, so let's wind up this session. We'll continue this chapter in tomorrow's session. All right, thank you.